Hello student, very good morning to all of you. Do you remember what were we discussing yesterday? I think we were discussing about the existence of arynes. There are the different example we have seen and proved that there is a existence of aryne, right? Number one, that benzene is treated with furan, undergoes a Diels-Alder reaction on acid catalyze produce the B-alpha naphthol. That is the first evidence or the first proof for existence of benzene intermediate. Second one, we have learned that benzene itself undergoes as a self condensation reaction producing as a biphenyl. That is the second proof for the existence of benzene intermediate. And third one, we have seen that by using as a mass spectroscopy, it gives some prominent peak at 28, 44, 76 and 152 clearly indicate that how fragmentations are take place and producing the prominent peak in the mass spectroscopy. And the last one, I think 1-amino benzotriazole when treated with lead tetraacetate producing the benzene intermediate. These are the four different examples we have seen that proved the existence of the aryne intermediate. What we are going to discuss today is the I think it is a last lecture of this semester. We are learning as a semester number 3. This is the last point of this semester at T.Y.B.Sc semester number 3. That is we are learning chapter number 6. The name of that chapter is aromatic, electrophilic and nucleophilic reaction. In that, the last point remaining that we are discussing, that is SR1 mechanism. And as we know that mechanism means what? A detailed study of sequence of steps and which are involved in the conversion of reactant into product is known as a mechanism. And those are good in mechanism. They can understood. They understood the organic chemistry is very well. So that is the basic concept regarding this. Now the SRN1 mechanism means what? What does it mean? So radical nucleophilic aromatic substitution. So that is the full form of that SRN1 means R stand for here is a radical nucleophilic aromatic substitution reaction. So that is the last point how it is takes place. Let us see the general nucleophilic substitution reaction. As we know that nucleophilic substitution reaction in a certain cases, under the rare cases, the nucleophilic substitution reaction is occur, and this is one of the SRN1 type of the also shows nucleophilic substitution reaction. Let us see here generally aryl halide. Suppose as aryl halide, as we know that the general formula or the general structure of aryl halide, this is the benzene get attached with that halogen atom, and that's why it is called as a aryl halide. And when it is treated with nucleophilic radical, generally as a nucleophile there is a radical, and as we know that the organic reaction taking place mainly via two position, the mechanism, one via ionic mechanism and second one via radical mechanism, and these two are very important one. And so the ionic, most of the reaction shows via ionic mechanism, that we know that, and few of them are proceeding via radical mechanism. And so this is a nucleophilic substitution reaction via radical nucleophilic substitution. So here what is happening, that halide group generally get replaced by this nucleophile, and that's why it is termed as, or it is called as nucleophilic substitution reaction. And radical means what? Free radical. Here I am putting one dot, means it is a free radical, and that free radical in this particular reaction, what it is doing, it is replacing that halide group by that nucleophile, and therefore it is termed as radical nucleophilic aromatic substitution reaction. And how does it happen, or where does it occur? And as we know that this type of the reaction, if you look at the mechanism, and then you can understood why this one nucleophilic substitution reaction occur in aromatic halide. And the example, best example is a Sandmeyer reaction. You might have Sandmeyer, that is a Sandmeyer reaction. Sandmeyer reaction, it is one of the, Sandmeyer is a scientist name, he invented that mechanism, and that's why Sandmeyer type of the reaction, where you can see such type of the radical nucleophilic aromatic substitution reaction are found in Sandmeyer type of the reaction. Let us look at the mechanism step by step, and as we know that the mechanism, it is a detailed study of sequence of steps which are involved in the conversion of reactant into product is known as a mechanism. And now how the mechanism takes place, how we are getting this product, let us see here the mechanism. Now let me begin the mechanism over here. You observe this mechanism carefully, and then you are going to understood how I am writing here. Let us see the starting compound is this one. Let me take as a double bond. I am going to put at a proper position. So here X, and then I am going to put as a double bond at this alternatively in this manner. When these substituent, not substituent, what is these, a substrate, when bombarded or when treated with the electron radical like as a sodium or some metal, they provide the electron to the species, to the substrate, and by using as a sum of the radical initiator, and they can generate the radical over there. And here the electron donor, we can call it as here electron donor over here. And when it donating as a electron, how the species are formed here, let us see here. Observe this transition state or this one carefully, and then you come to know that here is a radical anion. Radical, I am putting one dot and minus, that is called as a radical anion. And further this, the transition state when happen over there, and you are going to get over here, there is a X, and I am putting one of the radical over here. And that what is happening when the electron donor, means the radical initiator, initiate the reaction, and when in initiating that type of the transition state is formed, there is a radical anion is formed, and when that collapses into the further transition state where the halogen atom carrying or acquiring negative charge, and that benzyl or the aromatic ring acquire the radical, or it gets the radical over there, and that radical, as we know that, and when this again treated with, suppose as a, let us see here, suppose this type of the intermediate further treated with in a acidic medium, or you can use as a hydrocarbon, what you are going to get? You are going to get the formation of that one benzene back over there, here H and plus RX alkyl halide is the side product may produce in this reaction. But if this intermediate if you trap or if you treat with the nucleophile radical over there, one radical from here, another radical over there, they get formed like this in this manner, and what you are going to get in this particular reaction, you are going to get the nucleophile over here and plus X minus. In this way you are going to get, or what, for sake of convenience we can get over there, or this is a transition state where nucleophile here maybe as a radical anion is formed, and that further radical anion is converted or collapsed into this type of the product you are going to get as a nucleophilic substitution reaction, and that the transfer to second aromatic halide chain reaction, because there is a chain initiation reaction, chain propagation reaction, and when it is trapped with a nucleophile, that step is known as a chain termination reaction. So these are the different type of the stages or the steps are generated, or what we can call it as occurred in the free radical mechanism. All first one is a chain initiation reaction, means where that get initiated we are getting as a such type of the transition state, and that where the aryl group acquire or gets the radical charge, whereas halide atom get the negative charge when it is trapped with or treated with that acidic medium. It produces the benzene and the side product is alkyl halide, and when it is treated with nucleophile radical, it can generate the new free radical, and when it is trapped with or get terminated with this specific solvent or a specific reagent, we will get the nucleophile as well as the transfer of second aromatic halide, or you get transfer of second aromatic halide, that is a chain reaction, because this free radical reaction, chain reaction, and due to that reason we cannot stop that. Such type of the reaction is uncontrollable, and therefore it is very risky to isolate, or what we can call it as a stop at a particular reaction. So that are the what we can call it as a chain initiation reaction, chain propagation reaction, and chain termination reaction. In these three ways of these reactions are taking place. Now when this is the known as a mechanism of SRN1 reaction, or this is the mechanism, this type of the mechanism or occur in a Sandmer reaction. Sandmer is a scientist name, he invented such type of the compound. So in this substitution, the aryl halide accept an electron from radical initiator and form a radical atom. We know that radical anion, and this gets collapsed to aryl radical and halide ion. The aryl radical reacts with the nucleophile to form a new radical, that is a anion, which gets on to form substituted product by transferring its electron to new aryl halide in the chain propagation. Alternatively, the phenyl radical can abstract any loose proton from the proton donor, forming arene, and in a chain termination reaction. And the involvement of radical intermediate in a new type of nucleophilic aromatic substitution is supposed by the observation that they contain aromatic chloride and iodide in reaction with potassium amide. The chloride and also bromide reaction proceed through a classical arine intermediate and iodide by radical mainly and to form some extent via arine mechanism. For example, 5-iodo 1, 2, 3, 4. So let us see the example of this, how the actual reaction takes place and what type of the product is formed here. For example, here I am taking the example of this compound. Starting compound is here methyl group, here again as a methyl group, and then here also as a methyl group, and here I am taking as a iodine over here. The name of this compound is if you number from here 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So here the 5-iodo 1, 2, 4 trimethyl benzene when it is treated with a sodium amide in a NH2, as we know that this is the name of this compound is a sodium amide. And look at here, there is a hydrogen atom at ortho position, so that what it will do, it will abstract NH2 minus will abstract the proton from here and form as a intermediate, benzene intermediate over there. And so like this, so you are going to get here you can write as a methyl group is nothing but as a CH3, here methyl group, and then the NH2 minus can attack either this side or it can attack on this position, so that it will produce or it will give the two product, one product which is like this, here methyl group, another methyl group here, another methyl group over here, and now here is a H2N. This is one of the product. Another product you may get over here. Here is a methyl group, another methyl group here, another methyl group, and we can attach methyl group this side. So these are the product you are going to get over here. Among these, which one is a major and which one is a minor? If you see over here, this one treated with amide gives, this is the first compound we can call it, and this is the second compound, right? This not this first compound and the second compound, this one. And now this one generally we are getting, this is 1 as to 0.6%, means this one we are going to get in a major percent, and this one is a minor percentage of this one we are getting. So this is the product we are getting, the ratio of that thing. The presence of an unactivated substrate trunk base and formation of along with normal substitution product indicate the reaction proceed through benzene intermediate, because this benzene intermediate then and then we are getting as a product, and among these two, one is that is the experimental proof is given over there. So in this way I think we have completed all the syllabus of T.Y.B.Sc semester first, that is course number CS33 organic chemistry. And now let me give some important questions on this chapter. Let me discuss that one. So how the nature of question number, nature of 1 mark question appear in the exam. So let us see that type of the, suppose list any 4 activating group of aromatic ring for electrophilic substitution reaction. And as we know that aromatic compound easily undergoes electrophilic substitution reaction, and when there is a electron donating group such as methyl group, ethyl group, OCS3, alkoxide, methoxide, NH2 group, NHR group, OH group, and those are releasing electron or giving electron to the benzene ring. They are activating such type of the list. You have to provide, you have to write down in an exam. You will get the at least there 4 is given, so you have to mention such type of the group over there. Then nitrobenzene on nitration gives meta-dinitrobenzene. Why? As we know that the structure of nitrobenzene, and nitrobenzene it is a monosubstituted benzene, and look at the nitrobenzene. What is the nature of that nitro group? Here the nitro group act as a electron withdrawing group, and as we know that by knowing the resonating structure, we know that the 2 position are deactivated due to this nitro group. Only the position is sufficient to attack electrophile remains as a meta, and that's why it giving as a meta product, and that's it. That is the answer. In this way you have to give. You just say NO2 group is electron withdrawing group. Electron withdrawing group are meta director, and therefore nitrobenzene always gives meta-dinitrobenzene on nitration. So that is the answer you have to give in an exam. Then according to bromination, acetanilide on bromination gives para-bromo acetanilide as a major product, right? And as we know that the structure, first of all you should know the structure of the acetanilide, then and then you can predict the product. And as we know that there are 5 reactions which are commonly observed in aromatic compound. Which are those? First one is a nitration, second one is a sulfonation, third one is a halogenation, fourth one is a Friedel-Crafts alkylation, and fifth one is a Friedel-Crafts acylation reaction. These are the commonly observed in a aromatic compound. And first you need to know what is NHC double bond OCS3 group. It is a bulky group and it is a electron donating group, and therefore, and when it is a bulky group, it is a what kind of the director it is? It is a activator. Benzene ring get activated. All the position of that benzene get activated. But as compared to meta, ortho and para are more activated position, and due to the bulkiness of that acetanilide group, the incoming group electrophile prefer to attack at para position because there is no steric hindrance. It is and that's why we are getting as a meta product. Means bromination we are carried out. Bromination Br2 in presence of AlBr3 you can call it, or FeBr3 you can. That are the Lewis acid. Without Lewis acid there will be no reaction. Remember that point also there. So this is in this way you have to give the answer. And next one, presence of concentrated H2SO4 in nitration reaction is essential. Why? If you are not adding the concentrated H2SO4, who is going to play the role of acid as a catalyst there. And because as a Laurie-Bronsted theory, here HNO3 is act as a base, and where at an equilibrium concentrated H2SO4, it is acting just like as acid, and therefore it generate the electrophile. If it is not used there is a no generation of that nitronium ion electrophile, and once the electrophile is generated, in the second step it can attack to the benzene nucleus and form the sigma complex. And as we know that rhenium ion, or we can call it as a valent intermediate, are well stabilized due to the resonance, and we are getting generally. So in this way you have to explain, you have to give the answer of the. Or one more question maybe, what is the sigma complex? Just now we have seen sigma complex is formed when the electrophile is attacked or valent intermediate, and how it we know that how to show that benzene electrophile attack, and there you have to put one positive charge, so that is the electrophile complex. And what is pi bond? And whenever there is a attack of electrophile, first formation of the pi complex, even though we cannot isolate, but we can prove the existence of that formation of the pi bond. So in that way you have to only show the benzene, and then put one arrow, just line over there and attach it, so that is called as a pi complex. So that are the basic concept you should remember while answering such type of the questions are there. Again one that is the benzene undergoes electrophilic substitution reaction with Br2 in CCl4 rather than addition reaction. Why? As we know that the nature of the aromatic compound, they undergo, even though they containing as a carbon-carbon double bond, they do not show as a addition reaction. If they show the addition reaction, they will lose their aromaticity. Means aromaticity is nothing but as a stability is obtained, a stability are getting by that compound. And once if you do the addition reaction, it completely lost its stability, and therefore aromatic compound do not undergo as a addition reaction similar to as alkene, and instead they undergoes as a substitution reaction. In that way you have to provide the answer, or you have to give the answer. Then define diisocoupling reaction. As we know that diisocoupling reaction means what? Diazonium salt treated with mainly as amines, mainly as dimethylamine or trimethylamine aromatic amount, they get coupled at para position, and azo compound are formed, that is N formation of N double bond N. So that is mainly in the so that is called as a diisocoupling reaction. And then it may be or what is Friedel-Crafts alkylation reaction. What is Friedel-Crafts alkylation reaction? As we know that a reaction, Friedel-Crafts reaction, a reaction in which or Friedel-Crafts reaction is a electrophilic substitution reaction in which one or two hydrogen atom of the aromatic nucleus are substituted by alkyl group is known as Friedel-Crafts alkylation reaction. That is the definition you have to provide over there, or you have to give them. And so Friedel-Crafts acylation reaction, same thing is, same definition you have to give. The Friedel-Crafts acylation reaction is a reaction, Friedel-Crafts acylation reaction is a electrophilic electrophilic substitution reaction in which one or two hydrogen atom of the benzene nucleus are substituted or replaced by acyl group, RC double bond O group is known as a Friedel-Crafts acylation reaction. So in this way you have to give, you have to provide the answer of this question. Or what is that NN dimethyl aniline undergoes diazo-coupling reaction at para position. Just now we have seen, so NN dimethyl, if you bring the structure of NN dimethyl aniline in front of you, you will see that NN dimethyl aniline, that is a bulky group, which is a electron donating group, and donating group, they direct the they are the activator, and they activate ortho and the para position. But ortho, there is a bulky group, due to the two methyl group are the bulky, they are not, there is no sufficient space for accommodation of that that group at ortho position, and therefore preferentially that exclusively the electrophile is going to attack at para position. So that is the reason you have to give in this way. So that are the what we can call it as a 1 mark question. Some of the important question we have discussed over here. Now maybe for 2 or 3 mark question, maybe over there, what is write the mechanism for bromination of benzene. As we know that the mechanism of bromination, halogenation, nitration, sulfonation, then halogenation, Friedel-Crafts alkylation, as well as acylation. This type of the question we already seen everything. I think this and some of the predict the product, that type of the question may appear in the exam. So be prepare the step by step, you learn, you carefully read the book. Some of the you can refer as a textbook, or those are the advanced learner, they can use as a organic. That is, I already suggested you that the Clayton is the best book, or what we can call it as a Morrison Boyd. So these are the some of the reference books you can refer for your most to understand this type of the concept, organic concept. So I think with this we have, again let me what we can call it as a best of luck for your study and coming examination. Let me stop today here, and again we will meet in the next semester, in the 4th or the last semester, and where we are going to learn very interesting, or the what we can call it as a new topic for organic chemistry, that is a spectroscopy. What is that spectroscopy, where it is used, what are the technique we are going to use there. So that type of the thing, as well as I think in that we are going to learn some of the reaction intermediate via Carbanian, or maybe as a some of the natural product you are going to study, how to arrive, how to find out the that natural product. I think that of the study we will see in the next lecture. I think with this let me again what we can call it as a issue all the best. Thank you, have a nice day.